So we look at the the Lagrange interpolations. So the interpolations is actually used when you have a experimental data. Let's say x naught, fx naught, or this is a y naughts. When you got x naught, y naught, maybe you have the point x naught, y naught, because you have y is fx. So you have a set of point, let's say x naught, y naught, x1, y1 until xn, yn, and then you want to find given a value of, let's say, xk. Okay, xk is not you have a x naught, xk not in the list, but so you want to you want to find fxk here. Mean you got x naught, x1, xn, and its corresponding fx value. Now, given a xk value which is not in the list, you want to find the fxk values there. And we have several techniques to solve this problem. One of the technique that we use, we use the Lagrange interpolation techniques. Is and then is actually we construct from the point given there, we can construct the polynomial. Either you have a if you just connect 2 point only, you will get linear. 3 point you get quadratic, and then 4 point you get cubic. So we are going to construct a polynomial of degree n, and then based on the Lagrange interpolation techniques. Then for Lagrange interpolation, we have the fx can be approximated with a polynomial of degree n and is equal to the summation of the Lix fi, where the I from 0 to n. If linear, then n is 1. We got 2 points, so 0. We start the point, we indicate the point from 0, 1. So, for linear approximation, n is equal to 1. So for linear approximation or first order, so n is up to 1, so I from 0 to 1. That's why you got L naught x f naught, summation, and then plus with L1 x f1. So what is the L naught L1 here? So Lix is given by, this is a product, this symbol stands for the product, where when I equal to 0, so you have x minus xj, where the j cannot be equal to. So that's why for L naught, L naught, so you got the numerator x minus, it cannot minus from the point x naught, because j cannot be equal to I. That's why L naught is only x minus x1. Divided by the denominator is you see behind here the same, is only the x you replace by xi. That's why L naught for polynomial for linear approximation or is actually, you have one term only for L naught, which is x minus x1 divided by x naught minus x1. So L naught multiply f naught or y naught, and then L1 x f1. So for L1, x minus cannot minus from the point number 1. So x minus x naught divided, you see the denominator is only, you replace x by, if here L1, so replace x by x1 multiplied by f1. So this is for Lagrange interpolation for first order approximation or linear approximation. Mean we take only 2 data point. So when you take 2 data point, when you connect it, it's actually straight line. So it's a linear approximation. If we add up one more point, you make it become, this is a quadratic approximation. So for quadratic approximation, so n will be 0, 1, 2. You have the point 0, 1, 2. So you have L naught, f naught plus L1, f1 plus L2, f2. So in this case, you see the L naught compare with the compare in the linear approximation. L naught, if a quadratic, the L naught consists of 2 product here. That's why this symbol here. Because for L naught numerator, x minus cannot minus from 0. So x minus x1, x minus x2. So multiply f naught, and then you see denominator is only x, you replace by the point 0. So x naught, x naught. For L1, x minus the point cannot from number 1. So x naught, x minus x2. And then denominator, you just replace x here by x1. For L2, so x minus the point not from number 2. So x minus x naught, x minus x1 divided by, same thing, the x in the numerator you replace by x2. So multiply f2. So this is a quadratic approximation. Then if similarly, if you use one more point, you get the cubic, then you're up to L3, F3, and each L here you have, if cubic, so each L I x there, you will have 3 terms there. Here. Okay, so this is a graphical view for you to see the P1x. This is a P2 quadratic. And then this one is a cubic. So cubic, you see, you got each L, you have a product of 3 terms because here is 3. So if P4, so 1, 2, 3, 4. And then you up to L naught, L1, L2, L3, L4. So if a cubic polynomial degree 3, so the L from L naught, F naught plus L1, F1 plus L2, F2 plus L3, F3. And then how to get all these things is the same thing. When you want to construct L naught x, so you x minus the point not from number 1. So x1, x2, x3, because you're up to P3. So denominator is the same thing. Similar to numerator, you just replace the x by x naught, x naught, x naught. For L1, x minus a point not from number 1. So x minus x naught, you see x minus x2, x minus x3. And then for denominator, you replace x by number 1, x number 1. So for L, not L1, L2, L2, x minus a point not from number 2. X minus x naught, you see x minus x number 1 cannot minus with number 2. Because if you minus with number 2, x2 minus x2 is 0. A division by 0. And then x here for L2 replaced by x number 2. So for L3, L3, x minus a point not from number 3. So x naught, x1, x2. And then denominator replace x by number 3. So similar for the fourth order. So far any questions here?
No, Doctor.
No, teacher.
If no, it's very this one if we use calculator, then this is for up to I think fourth order formula. Then we are not going to we are going to do it using the Excel. I should change it to 3. Never mind. So the example number 1. We have the data actually generated by the function y equal to ln x, and round it to 4 decimal place. So from 1, 2, 3, 4, 5. We want to approximate f 4.5. So this is what we need to use interpolation. If I say approximate f4, you can directly read from table. So when x is 4, this is a corresponding y value. But now we want 4.5. So what is the y value here? So this is this. So in this problem, you need the interpolation techniques, and we solve this interpolation using Lagrange interpolation polynomial. So the question just so you can approximate f 4.5. If you 4.5, you notice is between 4 and 5, and the name interpolations. So make sure the data you are going to approximate is inside the list. If outside, then even though you can get the answer, but may not accurate. So make sure 4.5 contained in the list. So 4.5 contained in 4 and 5. So if you only take two data, that will be linear. So even quadratic, you need 3 data, then you take 3, 4, 5. So that 4.5 inside the list. Okay, cubic, then you take from 2, 3, 4, 5. But you cannot take 1, 2, 3, 4. If you take 1, 2, 3, 4, 4.5 will be okay, outside of the list. So mean is okay, 4 and 5 for linear. If you take 3, 4, 5 will be for quadratic. And then okay, if you take 2, 3, 4, 5, this will be for cubic. Okay, and then find the absolute error for each approximation. Okay, because we know this data is actually generated by okay the function y equal to ln x. Then okay, if you want to approximate y when x is 4.5, you can plug in. So ln 4.5, you get 1.5041. So this is what we call exact value, exact solution. Okay, the purpose we give you the exact solution so that we can calculate the errors there. Okay, you can calculate the errors. But in real application, you may not have the exact function. If you know exact function, then you just put in the function, you can get the value. But in real application, normally we don't know the exact function. That's why we need the interpolation techniques. Okay, and then so this one, if you calculate manually, and then using the calculator. So you want to use linear approximation, you take the last 2 data like this, and then you just plug in into the Lagrange interpolation formula for linear approximation. Fx is approximate using polynomial degree 1, which is given by this part is actually the L naught. L naught is x minus x1 divided by x naught minus x1 multiply and then multiply f naught. So this is a f naught, this is a f1. Okay, then you just plug in the x value given is 4.5. Okay, x1. Okay, so why we indicate I 0 to 1. So this is a x number 1 value, this is a x naught. Then you plug in. Okay, x1 is 5, x naught is 4. Then you just plug in. X naught is 4, x1 is 5. You just calculate manually this. Okay, this is a manual calculation. And then you can this is the absolute error, absolute value. Okay, this is the exact value, exact. Okay, you can take exact approximate the value that we obtain from the numerical methods. Okay, here like in Lagrange interpolation is approximate. So you take absolute value of exact and approximate. Okay, if we got the negative, we take the absolute value. That's why you take positive. So this is the error that we obtain. This is using a calculator. Okay, and then we are going to show you how to calculate it using Microsoft Excel. Okay, of course, linear approximation, you may calculate it using calculator. Later on, let's say cubic, maybe you still okay. Quadratic, maybe you still okay to calculate it. But cubic, quadratic mean order 4. Polynomial order 4, it may quite tedious to calculate and you may get wrong answer. That's why we are going to calculate it using Microsoft Excel. Okay, we go to Microsoft Excel. Where's my Excel? Here. Linear approximation. So we take the last 2 data, 4 and 5, so that 4.5 contain inside the list. And then I'm going to calculate compared to the manual calculation. Okay, I'm going to calculate this thing, L naught. I'm going to calculate L naught, L1. Okay, I'll show you. So here, so I'm going to calculate this cell, L naught, L1. And then the answer is actually L naught multiply F naught plus L1 multiply F1. So instead of you do manual this way, we are going to do in Microsoft Excel. So here, L is a function of X. So this is a L nodes. So L nodes for linear approximation. So remember your formula. L naught equal to x minus x number 1. So x naught minus x number 1. Okay, and then the x value that we are going to approximate its y value, where is actually 4.5. So x is 4.5. So I just put inside like here. I can put the exact. Okay, exact is actually equal ln 4.5. So I didn't round it. I just display it up to 4 decimal place. I didn't round anything. Okay, and then now I'm going to do is calculate in this cell. I'm going to calculate L nodes. Okay, so equal. Okay, x. X I store in the cell C number 1. So I click C1. Okay, and the x value I'm going to calculate to cell D5. So x is a constant. So for constant, remember we put the dollar in front and back of the column label. So okay, $C $1. So mean fixed column C, fixed row number 1. So when you copy it to down, copy it to mean the going down or copy the next column, it remain the position won't change. So always take from cell C1. So this is for constant value. So x minus x1. So you minus. Okay, click x1 is stored in D4. Okay, divide, and then I can copy the numerator. You see numerator and denominator. Okay, almost same formula. So I copied. So Control C. Okay, and then Control V to paste it, and then okay, I highlight the x, which is my $C $1, highlight it, replace by x naught. Any mistake? So D4 I have to change. Correct. My value something wrong. Okay, let me check. C1. Oh, I clicked wrong. You notice what I clicked wrongly. X minus x number 1. I click, which is the y. That's why the value is wrong. Okay, if wrong, you just click it back. So you see, x is C1, x number 1 is D3. So x naught is C3. Just now I clicked the wrong row. I click actually the y value. So this is a L node. Okay, L node. And then for L1, okay, for L1, you notice the correct form. L1 should be x minus x naught divided x1 minus x naught. Okay, for L1 you may key in. Okay, but I'm not going to key in. Okay, L1, of course, you can go to this cell, key in this formula. Okay, but I'm going to show you the technique where you no need to key in, and the technique can be applicable up to any. Okay, let's say you want to quadratic, cubic, okay, or up to polynomial degree 4. The same technique can be applicable. So what I'm going to do, okay, after you key in, make sure you key in the L naught formula correct. Okay, point to the left bottom cell. Okay, to get the little plus, click it, hold down, drag it. This is shortcut for you to copy. Okay, if you cannot copy this thing way, then you Control C, Control V also can. Okay, after that, okay, click inside the cell L1. Click. Okay, you see, okay, L1, because when we copy initially, okay, you see the formula. Okay, before I show you the shortcut. Okay, you see the formula that we key in. My x is stored in C1 because this is constant. So C $1. So that you see when you copy it, it still maintains C1 because you put $C $1. So when you copy it still maintain the same cell. And then x1 is actually D3. D3. Then I have I have divide, and then x naught is my C3. Yeah? X naught is C3, so minus D3. So when you copy the formula, okay, you copy the formula to the next column. So because this is dollar, so it's maintained, it won't change. So when you copy it, okay, to the next column, the formula D will become E. C become D. D become E. So you see, is it correct? So this is how Excel, okay, when you copy it, okay, if a formula initially D3, because you copy the next column, same row, that's why row maintain. So D become E. D become E. C become D. Okay, but the correct formula for L1, X, okay, C1. X naught is actually C number 4. X naught is C3. X should be C3. Okay, and then X1 is D3. Okay, correct formula should be here, right? So you see, okay, this one correct, this one correct, this one correct. Only the E3, E, you should drag it back. E, you should drag it back to C. When you see, or you click here, see. So this one, which is wrong, E should be drag it back to C3, which is the X node. Then you just drag it. So you, okay. So with this technique, you no need to key in. Because for linear, of course, you can key in. Quadratic maybe okay. Cubic a bit tedious. If order 4 more tedious. So using this technique, okay, you no need to key in. Make sure you just key in L not correct. You copy it, okay, to L1. Then click here. See, okay, just drag that cell outside of the list. Always drag it back to X node. Then the formula is always guaranteed correct. Okay, and then so okay, so the F 4.5. Okay, then so F 4.5 will be L nodes multiply, okay, F node plus L1 multiply F1. Get 1.497. Okay, and then the absolute error, take ABS, the exact minus here. So display, just display. I didn't round. Okay, you can round also, but I didn't okay. What I didn't round it. This is display only. Correct. 1.4979 0.0062 tally with, okay, what you obtain using manually. So any questions here? Okay, if quadratic, okay, if you calculate manually for quadratic approximation, so 4.5 is between 4 and 5. So for quadratic, we'll take, okay, the last three data, 3, 4, 5. So this is the data. Then similarly, you just need to plug in into the, okay, the quadratic, okay, interpolation formula. You can approximate F 4.5. So manually, if you do it, you may want to write this formula and then you plug in one by one. What's the X naught value, X1 value, X2 value, and then the F naught, F1, F2 into your, okay, into the, okay, quadratic, okay, Lagrange interpolation formula. Then you can obtain it. So before, okay, you want to key into the form, to calculate F 4.5 using the quadratic Lagrange interpolation formula, make sure you're familiar with the formula. when you understand the formula, this formula. So understand the L node here. So the L node is, okay, for quadratic, okay, because you got 0, 1, 2. So you got L node, F node, L1, F1, L2, F2. So L node, okay, when you're standing here, X, okay, our X is 4.5 minus, okay, not minus from this point, 4.5 minus 4, multiply 4.5 minus 5, divided. So the denominator, okay, just okay, copy your numerator and then 4.5 replaced by X node. Okay, and then we are going to use the same technique to calculate in Microsoft Excel as we did for the linear approximation. So this is, okay, for linear, and then if you got quadratic, okay, I'm going to copy this data. Okay, so I just put the L is a function of X. So for quadratic, okay, you will need to add in one more, okay, term here. Yeah. So X minus X number 2. Divide X node minus X number 2. So you just key in. Oh. Okay, the X, okay, value is here. So the X, okay, if you don't want to use a $C, $1, you may type in 4.5 also can. Okay, but if you put it into this cell, so next round, you can just change the, okay, the given X value and then change the exact K function, change the data. You can change your data XY, then the formula still maintain there and the calculation will be automatically changed. Okay, so X minus X number 1 here, multiply, okay, this one, if you're lazy to type, I copy. Yeah. So, okay, D, and then the next column is E. So I key in X minus X1, multiply X minus X2 here. So you see, the cell is, okay, highlighted. Divide. So, okay, for denominator, now you got two terms, so make sure a bracket. You put in a bracket first, and then you copy the numerator, Control C, highlight the numerator, Control C, put inside a parenthesis, a bracket, okay, at the denominator. So make sure your denominator you put bracket. If you don't put bracket, okay, this term x naught minus x2 will become multiplication. Okay, and then you select the cells $C, $1, change it to x naught. Change it to x naught. Okay, and then if you want to key into L1 manually also can. Okay, you want to key into manually also can, but I'm not going to key in. I'm using the technique copy as I mentioned just now. Okay, for L1 is x minus x naught, and then x minus x, not from number 1, number 2. So divide, this is x1 minus x2. You may key in manually one by one. Okay, but I'm not going to key in. I just need to copy, select the cell L1. You see, you have a cell which is always, okay, outside of the list, and I just need to drag it back. Then the formula I guaranteed is always correct using this copy, okay, editing technique. okay, because of the relative column in, okay, Excel. Okay, you see the formula. X is keyed in the cell C1. X1 is, okay, in this case is D11. Okay, D11. Let's see, D11, and then this is multiply. X is C$1. So D X2 will be, next column is E11. And then you, okay, in Excel, okay, divide is backslash. Okay, and then here, if I put it here later, you'll not see. So you have a bracket, okay, a bracket like this. You copy the numerator and then maintain C1, you change it to X0. So X0 is C11. So this is same, multiply. So C11 minus D11. Okay, so when the formula is copied, is you copied, you get, okay, $C1 will maintain because you fix. So D become E. This C1. E become F. And divide, okay. So C become D, D become E. So C, this one become D, D become E. Okay. So you see, okay, the formula X is correct. E11, okay, click back the formula, see how to see. Yeah. Oh, because this one I already copy, already edit it. Okay, initially you copy, you move like this. Okay, D go to E. Okay, E is actually still, this is actually the X2. This one is X2. Mean E is correct. E is actually X2. So X2 is here. So this, okay, the first product is correct. Only the F here, C11, F11, which is outside. But according to the formula, this should be X0. This should be X0. That's why, okay, what I need to do is I always drag that cell that I copied, and then which is outside of the list, drag it back to X0. Because, okay, when you see D, when you copy it, you get E. E11 coincidentally is, okay, belong to here. X minus X2, X1 minus X2. So the X, okay, you see X, initially you your X0 is in C. When you copy it, it become move to X1, which is correct. Only, okay, only this one. Because your X2, when you copy it, it move to here, outside the range. So, okay, become F, which is wrong. So you drag it back, then the formula is correct. Okay, and this technique provided you copy one by one. You copy it, let's say if you copy it quickly, 2, then is, okay, you copy the first one, okay, it outside 1, okay, and then if you didn't edit, you copy it directly, then you will confuse. So 2 outside of the list will be confused. So, okay, the technique, okay, you have to copy it one by one like this. Then this is wrong, drag it back, okay, and then once, okay, once the L1 is correct, then you only copy the L2. Then the same technique, just drag it back to X0. Okay, after that, your F 4.5 using quadratic approximation will be L0 multiply F0 plus L1 multiply F1 plus your L2 multiply F2. Okay. then if you want to just show to 4 decimal place, then you can calculate the absolute error, which is ABS, the absolute value, the exact value is in E1, so minus the approximate value. So quadratic error is smaller than linear. So any questions here for the quadratic? So manual, Microsoft Excel, and then so for the cubic, so you see when your the more point that you take, the calculation become tedious if you do manually. So 4.5 between the last two data, if you want to take cubic, then you need to take 4 data point. So it takes 2, 3, 4, 5, so that 4.5 is contained inside the list. So for 4 data point, we label from 0, 1, 2, 3. Then this is the formula for if you use cubic approximations. So this is the L node. This part is your L node F node plus L1 F1 plus this is the L2 F2 plus L3 F3. So L nodes numerator x minus the point node from 0, so x1 x2 x3. Numerator compared to denominator is only x, you replace by x node. So the same pattern replace to the L1 L2 L3. So this is a formula, and then you just plug in x is 4.5, plug in this is a x node value, this is x number 1, this is x number 2, this is x number 3. So this is your F node, F1, F2, F3. So plug in. So if you do manual, you write formula, you write down the value that you plug in, and then you key in, you calculate manually. This is the answer, 1.5026, and then you can calculate the absolute error. So you see, so when the n is increasing, the calculation become tedious, and you may calculate wrongly because you got 3 product each term there, and you may have rounding error. Then so we are going to similarly we are going to calculate it using Microsoft Excel. So you just make sure you calculate L node correctly. You copy it to get L1. You copy it and then click back this cell. You see that one outside of the range. Drag back to X node 2 times. So L1 is correct. You copy it to get L2. The same technique. The cell that outside of the range, drag it back to X node. So when L2 correct, you copy it to L3, click, the formula will be have a 1 which is outside of the range, drag it back to X node. So with this technique, you can quickly calculate each L value quickly, and then the F4.5, which is indicate the answer here, is your L node multiply F node plus L1 multiply F1 plus L2 multiply F2 plus L3 multiply F3. Then lastly, you can calculate the absolute errors. Then we move to Mac, but I copied the data first. Copy here. This is a cubic. Then this is my L is a function of x. So mean the L you take out from the x value. That's why we put L is a function of x. The x, now I got my exact is here. So L node is, remember the formula L nodes. I write it first. For cubic, L node should be x minus x number 1, x minus x number 2, x minus x number 3, divide by x naught minus x1, x naught minus x2, x naught minus x number 3. Okay, then we key in into the cell to calculate L nodes. Yeah, so equal. So x here C17, make it constant so that when I copy it to the next column, x maintained in the correct cell. So x minus x number 1. Click x number 1. So multiplication, make sure your asterisk there. Okay, and then if you're lazy to type this one, you can Control C. Okay, and then edit D and X E D E F, because each X value is stored in the column by column. So you see, this is D19, E19, F19. Okay, and then divide is a backslash. Okay, denominator because 1, 2, 3. Okay, Excel, okay, the limitation, you cannot show formula in natural display like mathematics. So it's like programming. So 3 term, you have to use the parentheses. So divide, so you put the bracket first in case you forget to put it. Later on, copy your numerator, highlight it, Control C, put inside the bracket, Control V. Okay, select the X. In my case, it's C17. Change it to X naught here. X naught. X naught. Okay. Then the L. Okay. And before you copy, make sure you double check whether you key in the L naught formula correct. X. So X1 D E F. So X naught will be C. Correct. Okay. Once you confirm is correct, copy. Copy one by one. So copy and then click inside the cell C1. Click it or click the formula on top. You will see one of the formula which is correct, wrong. Because when you copy it, L1 will move to X1. Cell X1, you copy it, you move to cell X2. X2 to X3. X3 outside the list. Outside the list. Okay, but according to L1 formula, L1 formula, let's see, L1 should be X minus X naught, X minus X2, X minus X number 3. So this will be X1 minus X naught. Okay, X1 minus X number 2. So X1 minus X number 3. So when you copy it, X1 actually, this one move to here. X2 move to X number 3. X3, when you copy it, will outside of the list because 3 it move to the next column, which is outside. You can see here. So mean X1 formula tally to the second product. X2 to X3. X3, you should drag it back to X naught. Okay. So provided you copy it one by one, you copy it straight away. This one will 2 cell outside the range. This one 3. Then later on we'll confuse. So you have to copy it one by one. So once this is correct, you copy. Then just drag back to X naught. Okay. Okay. So quickly with this technique, you can calculate L naught, L1, L2, L3. Then your F 4.5 will be L naught, okay, multiply F naught plus L1 multiply F1 plus L2 multiply F2 plus L3 multiply F3. Okay, and the absolute error, okay, the exact minus approximate. So you see, cubic we get even smaller than, or if we compare only linear, so cubic you see, okay, the smallest error compared to quadratic compared to the linear, but also depend on the data. Okay, so any questions here?